Wondernauts. Welcome back to the channel where we dive deep into concepts that make you think, learn, and get inspired. Today, we're talking about a fundamental mechanical system that powers many everyday machines, the slider crank mechanism. So, let's break it down. The slider crank mechanism is a simple yet powerful system used to convert rotary motion into linear motion, or vice versa. It's the heart of engines, compressors, and even old-school steam locomotives. But how does it work? Here's how. The crank rotates, creating circular motion. The connecting rod links the crank to the slider. The slider moves back and forth in a straight line. And the frame holds everything together. As the crank turns, the connecting rod pushes and pulls the slider, converting the rotational movement into a smooth back and forth motion. This is the same principle powering your car's engine pistons. Let's see how this looks in a joint graph. Joint graphs are visual tools used to analyze the connections between different parts in a mechanism. The variation of displacement, linear velocity and linear acceleration of the point on the tip of the crank with time is shown. See how the linear velocity and acceleration are flat lines with velocity being constant as the angular velocity is constant and linear acceleration is zero as the velocity is constant. Similarly, for a point on the slider, the variation of displacement, linear velocity and linear acceleration is plotted. See how the linear velocity and acceleration varies with time. That's the slider crank mechanism and how we use joint graphs to make sense of it. Simple, efficient, and widely used. If you found this video helpful, give it a thumbs up and subscribe to Wondernaut for more fascinating breakdowns of everyday engineering.